Next, we're going to talk about rules of monomials. And the first one we're going to talk about is multiplication. Some of these we've done already as a review of some of the new material. But I'm just going to go through them again to make sure you understand them and make sure you understand where these things are coming from. So if I'm doing multiplication, the big thing you need to understand, if I have something like x cubed times x squared, well, that means I'm going to multiply those two things together. But when I do that, a common mistake is people try to say that that's x to the sixth, and that's just wrong. What this means is if we have x cubed, that's the same thing as x times x times x. And if we have x squared, that's the same thing as x times x. So if we're multiplying those together, what we're really going to have is x to the fifth. So when we have the same base and different exponents, we keep the base and we add the exponents together to do that. Now, what happens when you have coefficients in front? Like if I had something like 2x cubed times 3x to the fourth. Well, in that case, we're going to multiply the coefficients just like normal. So 2 times 3 is 6, and then we keep the x and add the exponents. So 3 plus 4 is 7. So that would be 6x to the 7th. And then that leads us to a polynomial. If I have something like this, 2x squared times 4x cubed plus 2x minus 1. Let's just say we have that. Well, if I distribute the 2x squared to each of these terms, 2x squared times 4x cubed would be 8x to the fifth. I multiply the coefficients, I add the exponents. 2x squared times 2x would be 4x cubed. Again, I multiply the coefficients, I add the exponents. And then 2x squared times negative 1 is minus 2x squared. If I had any like terms, I would add the like terms, but in this case, I don't have any. Next, I want to talk about division of monomials. If you have something like x to the sixth over x to the fourth, that's the same thing as writing x down 6 times and writing x to the fourth. That would be 4 times 4x. And then we learned when we were dealing with fractions that as long as you have the same thing on the top and the bottom, those things can be canceled out. As long as they're factors, they're multiplied together. So since all of these are multiplied together and all of these are multiplied together, I can consider all of them factors, okay? And I'm allowed to cancel a factor from a factor as long as one comes from the numerator and one comes from the denominator. So if I look at this, I see that I've got an x there, x, 4 x's that can cancel, leaving me with an x squared left over. So that leads me to a simple rule for dividing monomials. If you have the same base, then you can take the top exponent minus the bottom exponent. So that would be x to the 6th minus 4, and that leaves you with x squared. So you can do subtraction when you have division of polynomials. And similarly to that, if I have something like 10x to the 7th over 5x cubed, I can take the coefficients, and I do that normally. 10 divided by 5 is 2. And then I keep the base x and subtract the exponent. 7 minus 3 is 4. So that answer would be 2x to the 4th. Okay, so that's the very simplest division of monomials that we can have. So that leaves us with a problem when we're dealing with division. If we have something like this, if we think about that, we said that we keep the base and we subtract the exponents, the top minus the bottom. Well, if we do that, 2 minus 4 is negative 2. So we end up with a negative exponent. But there's a rule in algebra that says you're not allowed to have any negative exponents in your answers. So we need to have another way to do this one. So I'm going to show you another way, and hopefully you'll understand how this works. So if I've got x squared over x to the 4th, isn't that the same thing as on top we've got x times x, and on bottom I've got x times x times x times x, and I can still cancel out the two things they have in common. So what that does is that leaves me with a 1 on top and an x squared on the bottom. So if you look at these two things, okay, technically we started with the same thing. So these two things must be equal, and they are. And another rule for negative exponents that you need to understand is if you have a negative exponent, you're not allowed to have negative exponents in your answer. So in order to get rid of the negative exponents, what you're going to do is you're going to take that negative exponent, change it to a positive, and you're going to put it in the opposite position. Right now, that is x to the negative 2. It's understood to be over 1. Okay, so if you put that in the opposite position, you're going to take the x squared and you're going to put it on the bottom. And you can do that for any negative exponent that you have. Okay, so if I have something like x to the negative 5th, well, that's the same thing as 1 over x to the 5th. I change it to a positive and I put it on the bottom. So what if my negative exponent is on the bottom? If that's the case, let's think about what that means. We said that any negative exponent can be moved to the bottom of a fraction as a positive. So if that's the case, isn't that the same thing as 2 times x squared over 1, which is 2x squared? So look at what we've done. That negative exponent has been changed to a positive and just put on top. There's no need to do all this work. If we have a negative exponent, we're going to change it to a positive and put it in the opposite position. If it's on the numerator, it's going to go to the denominator as a positive exponent. If it's on the denominator, it's going to go to the numerator as a positive exponent. So if I have something like this and I want to simplify it, first of all, I'm going to take all of the negative exponents, I'm going to change them to positives, and I'm going to put them in the opposite spot. So if it's on the numerator, I will put it on the denominator as a positive. If it's on the denominator, I will put it in the numerator as a positive. Now the 2 is not an exponent, so it just stays where it is. X to the 5th is positive. It stays where it is. Y to the negative 2 is a negative. I'm going to change it to a positive and put it on the bottom. Z to the negative 3 is negative. I'm going to change it to a positive and put it on the bottom. Then I can move to the bottom. X to the negative 2 is negative. I'm going to change it to a positive and put it on top. Y cubed stays where it is. It's already positive. Z to the negative 5 was negative. I'm going to change it to a positive. I'm going to put it on the top. And then to simplify this, I'm going to work normally with my rules for multiplication and division. So if I'm doing that problem, first of all, the 2 doesn't cancel with anything. It stays where it is. So I've got a 2 on the top. The x to the 5th and x squared, well, they're beside each other. Anytime we have two monomials beside each other, we keep the base and add the exponents, as long as the bases are the same, and they are. So we keep the base, x, and add the exponents, so that's x to the 7th. The y's are beside each other, so we keep the base and add the exponents. So if they're beside each other, both in the numerator or both in the denominator, we keep the base and add the exponents. If they are over top of each other, like we have with the z's, think about that, that's a division, so we're going to subtract. Keep the base and subtract the exponents, okay? So here, we've got z to the 5th over z cubed. 5 minus 3 is 2, so that z squared goes on the top. Now, how do we know whether our z squared goes on top or bottom? Well, this is a real simple rule. Whichever exponent was the biggest is where your leftovers are going to be. So here, the z to the 5th, the 5 is bigger than a 3. So when I subtract those, I'm going to subtract the highest number minus the lowest number, 5 minus 3. I have a leftover of 2. Wherever the bigger number was is where my leftovers will go. And 5 minus 3 is 2. My leftover z squared goes on top because that's where the bigger exponent or the higher exponent was. Next, I have powers of monomials. If you look at this, I have a monomial to a power. And what I'm going to do is that power has to multiply by all the powers on the inside. Anytime I have a power on the outside of my monomial, I have to deal with that before I can do anything else. So I have to take this power and I have to multiply it by all the powers on the inside. Now, this rule only works if there is a monomial on the inside. Remember, if you have a binomial on the inside, okay, that's different than this. This means I have to write it down twice and FOIL. Okay, so that's x squared plus 4x plus 4. This means, well, I could say I need to write that down twice, but I wouldn't be FOILing, I would just be multiplying. In that case, I would get 4 times 4 is 16. X cubed times x cubed is x to the 6th. Okay, so that's one way to do it. But with that one, I would suggest that you do it a different way, because this will save you some time. If you have an exponent on the outside of the parentheses, take that exponent and multiply by all the exponents on the inside. Now understand this 4 is understood to be 4 to the first. That's x cubed. So I'm going to take the 2, I'm going to multiply it by all the exponents on the inside. So that's 4 squared, because 1 times 2 is 2. And x cubed and 3 times 2 would be x to the 6th. That gives me a 16x to the 6th. Same answer, I did it a different way. So that leads us to solving any monomial. Okay, and so if I have a monomial, and here's one, this is kind of a complicated one, but as long as you follow these 3 simple steps, you should be able to do all of them correctly. You just have to make sure you follow it one step at a time. Don't try to do too much in one step. Show your work as you go. To solve monomials, first you're going to get rid of all powers outside of the parentheses. So what I'm going to do is I'm going to follow this 3-step method and show you the process of solving a problem like this. Okay? Now, there are a lot of different ways to do these. This is just what I've found to be the easiest way to teach this. So you're going to get rid of all powers outside the parentheses first. So if you look at this, here's a parenthesis, there's a power on the outside. In order to do that, we learn that we take that power and we multiply all the powers on the inside. Now remember, any coefficient that you have is understood to have a power of 1. Don't forget to take that 3 and multiply by that power of 1. If you forget that, you'll get a bunch of the coefficients wrong and your answer at the end is going to end up being wrong. So be real careful about that. So this would be 2 to the 1 times 3. That's 2 cubed. X to the 2 times 3 is x to the 6th. This -1, I'm going to multiply by all the exponents on the outside. So that gives me a -2. Remember, the -2 is not an exponent, so you do not change its sign. So -2 to the 1 times -1 is going to be -2 to the -1. X to the 3 times -1 is x to the -3. So notice here we've got some negative exponents we're going to have to deal with. We'll deal with those in the next step. Here, 4 to the first, that would be 4 to the second. X to the 2 times 2 is x to the 4th. This is 3 to the -2, so that would be written down below. And then that would be x to the -4. Now, looking at this, understand these parentheses really don't mean anything other than I'm trying to make sure you understand this is not x to the 6th minus 2 to the -1. That is times -2 to the -1. We will get rid of that in just a minute. Now, the second thing I have to do is get rid of all negative exponents. So remember, if it's a negative exponent, we change it to a positive and move it to the opposite spot. If it's on the numerator, it goes to the denominator as a positive. If it's on the denominator, it goes to the numerator as a positive. So looking at this, I'm just going to go straight across the top and straight across the bottom, and I'm going to get rid of all the negative exponents. 2 cubed is positive. I'm going to leave it where it is, and since I'm leaving it where it is, I'm going to go ahead and make it an 8. X to the 6th stays where it is. -2 to the -1. -1 is negative, so it's going to move it to the bottom as a positive 1, but it's still going to be a -2. It's just a -2 to the positive 1. Now, we don't change the value of the coefficient. We just change the exponent to a positive and move it to the opposite spot. X to the -3 becomes x cubed on the bottom. 4 squared stays where it is. 4 squared is 16. I'm going to go ahead and write that out. X to the 4th stays where it is. 3 to the -2 goes to the top as a positive, 3 squared. And then x to the -4 goes to the bottom as x to the positive 4. Then I need to work on my coefficients or my number values first, and then I'll deal with some of the exponents. So here, if you see, this is 3 squared. Well, 3 squared is 9, and 9 times 8 is 72. So I'm going to go ahead and write that out. 16 times negative 2 is a negative 32. I'm going to go ahead and put that in there. And then that x to the 6th, I'm going to keep it on the top. There is nothing up there to put it with. And look down here, I've got x to the 4th times x cubed times x to the 4th. Now remember, this is a negative 2, it is not minus 2, okay? So x to the 4th times x cubed times x to the 4th. I keep the base, x, and I add the exponents. So 4 plus 3 is 7, plus 4 is 11. And now I'm going to simplify that fraction. Well, this is a negative. 72 over 32. 8 goes into both of those. So 72 divided by 8 is 9. And negative 32 divided by 8 is 4. So that'll be a 9/4. And then look at your variables. I've got x to the 11th on the bottom, x to the 6th on the top. So I have 11 x's, and we have to subtract 6 x's from it. So 11 minus 6 is 5. Where was the exponent bigger? On the bottom. So I have x to the 5th left over on the bottom. And this is my answer, negative 9 over 4x to the 5th. So here's another one I want to make sure you understand. We're going to use the same method. First, we're going to get rid of all of the exponents on the outside. So that means I have to distribute or multiply the exponents times all the exponents on the inside. This is understood to have a 1 there. This is understood to have a 1 here. So 3 to the 1 times negative 2 would be 3 to the negative 2. X to the 2 times negative 2 would be x to the negative 4th. Y to the negative 3 times negative 2 would be y to the positive 6th. Z to the negative 2 times negative 2 is z to the positive 4. 2 to the 1 times 3 is 2 cubed. X to the 3 times 3 is x to the 9th. Y to the 2 times 3 is y to the 6th. Z to the negative 3 times 3 is z to the negative 9th. Then look at the bottom. There's nothing I can do there. There are no exponents on the outside, so I'm just going to bring those down. Then I need to get rid of my negative exponents. So any negative exponent is going to go to the opposite spot. And again, when I do this, I just go straight across the top and straight across the bottom, putting things where they need to go. So 3 to the negative 2, that's going to go to the bottom as 3 squared. X to the negative 4 goes to the bottom as x to the 4th. Y to the 6th and z to the 4th stay where they are. And again, I just go in order so that I'm not leaving anything out. 2 cubed stays where it is. X to the 9th, y to the 6th, both stay where they are. They were positive. Z to the 9th goes to the bottom as a positive. 4x cubed stays where it is. Y to the negative 3 goes to the top as a positive, and z to the negative 4 goes to the top as a positive. Next, I'm going to deal with my numbers, my coefficients. 2 cubed is 8, so I'm going to have that in the front. 3 squared is 9, times 4 would be 36. So the bottom numbers are 9 times 4, 36. Then I'm going to, if I have numbers both on top, variables that are in common, I'm going to add those exponents together. So here, let's see, I've got y to the 6th and y to the 6th. So that's going, and y cubed. So 6 plus 6 plus 3 would be y to the 15th. Now I don't want to forget about my x to the 9th goes right here. And then my z's, z to the 4th and z to the 4th would be z to the 8th. On the bottom, I have x to the 4th and x cubed, so that's x to the 7th and the z to the 9th. Now I'm going to simplify the fraction using the numerator and denominator. For the 8 and 36, 4 goes into both of those. So 8 divided by 4 is 2, 36 divided by 4 is 9. Look at the x's. I have 9 on top, 7 on bottom. I have 2 left over on top because that's where the exponent was biggest. Y to the 15th stays where it is. There's nothing to simplify with that. And then we've got z to the 9th, z to the 8th. The 9 is bigger. 9 minus 8 is 1. So I have 1z left on the bottom. So here is my answer. One thing I do want to make sure I mention is what happens if you have something to a 0 power. We need to talk about what that means. So let's just think about it. If I had something like x to the 5th over x to the 5th, well, we learned earlier in algebra that if we have the same thing on top and bottom, we're allowed to cancel it out, and when everything cancels, we end up with 1, right? Not 0, but 1, okay? We also learned in this lesson that x to the 5th over x to the 5th, that would be the same thing as keeping the base and subtracting the exponents. So that's x to the 0. Well, it must be that these two things are equal. See that? So what this leads to is the rule that anytime you have a 0 exponent, the answer is 1. Okay? So x to the 0 is 1. 5 to the 0 is 1. 2x squared y cubed z to the 5th over 5x cubed y to the 2nd all to the 0 power is 1. So anything to the 0 power is 1 no matter what, because of the rules that we learned in this section. So that's something you need to be aware of. So far everything we've learned in this lesson has been review of Algebra 1, but I want to make sure I get you to understand where does the Algebra 2 come into play here. And we'll find more ways that we're going to use this stuff as we move forward. One thing you haven't really had to do yet with exponents is understand what happens if those exponents are variable. We will deal with that a lot in Algebra 2. But the rules are basically the same. You're not going to have anything special that you're doing. The rules are always going to be the same, but your answers are going to be a little more complicated, and they're going to look a little bit different, and they're going to involve more variables. So if you look at this, here I have 6 to the 2n over 6 to the n. All of that is to the 3rd power. Now remember, if we have something to a power, we take care of the power first. So that 3 can multiply by all the powers on the inside. So if I do that, I keep the 6. That's going to be 6 to the 6n, because 2n times 3 is 6n. And then on the bottom I have 6n times 3 is 3n. Okay? And now if you look at what you got, we have a common base. The common base is 6, and we have different exponents. Well, what was the rule when we were using exponents? We had a common base, and they had exponents on top of each other. Well, we keep the base, and we subtract the exponents. The bigger one minus the smaller one, and then the leftovers go where the bigger one was, right? Well, if you look at this, which one's bigger, 6n or 3n? Hopefully you're saying 6n. So I'm going to subtract 6n minus 3n. So I keep the base, 6. 6n minus 3n is 3n. That's all I can do. I'm not going to try to do 6 cubed or anything like that. I'm just going to leave it like this. It is okay to have a variable in your exponent, no problem. And we'll learn more about this as we move through the Algebra 2 class. With this one's very similar. There is no exponent on the outside of parentheses, but we do have 2 exponents over top of each other. Now with this, since we don't know what n is, and we don't know whether n is positive or negative, we really don't know which one of those is bigger, okay? If that's the case, you're always going to take the top minus the bottom, okay? So I'm going to keep the base, x, and I'm going to take the top exponent, n plus 1, and I'm going to subtract the bottom exponent, 2n minus 5, from it. Now, here's a very, very important thing. I'm subtracting that whole thing. So if I'm subtracting that entire thing, that means I have to distribute my minus sign. If I forget to put this in parentheses and distribute my minus sign, I'm going to get them all wrong. So you have to be careful. Remember, we reviewed polynomials earlier. This is why. Okay, so I keep the base, x. And what this really means, and I'm going to do some extra steps here. You might not need to do all these. N plus 1 minus 2n plus 5. That's what I have when I distribute the minus sign. And now I'm going to add my exponents. So I've got x, n minus 2n is negative n, and 1 plus 5 is plus 6. So this is my exponent. Now, some students might be tempted to try to move that down to the bottom, but remember, if n were negative, then we would have a positive number up here. Okay, we don't know whether n is positive or negative, so we can't say that that needs to go on the bottom or the top, because now we're dealing with variables. It's a little different when you have variables involved than when you didn't have any. So I'm going to do one more, and hopefully you'll have a good understanding of monomials. With this one, I have 2 monomials with a common base, x, and they both have exponents that involve variables. My rules here again are not any different. I'm going to keep the base, x, and I'm going to add the exponents. So I have 2n plus 4 plus 3n minus 6. Since that's a plus, I don't have to worry about distributing it. It's kind of already done for us. And so I keep the base, and I add my exponents. 2n plus 3n is 5n. 4 minus 6 is negative 2. That would be my answer.